Hi again, it's Professor Lucien. This is lecture 26. We're in the final module, and so we're going to start talking about health standards, and I wanted to start with industrial hygiene because that's how I cut my teeth into safety, is being hired as an industrial hygienist with Minnesota OSHA, and so that's where everything began for me. So I'm going to try to give you a very broad overview, specifically give you some of the basic things, compare a few concepts within IH, epidemiology, exposures, things like that, and then show you the Z tables and then some other resources. So industrial hygienists are meant to focus on the health-related topics. So in Minnesota, because they have a state-run OSHA program, we had the health inspectors, we had the construction safety inspectors, and we had the general industry safety inspectors. And so as IHs, we traveled all over the state. Now, I really loved my job, and so I started spending more time with both the construction and the general industry safety, and so I kind of learned how they did their job too. So when I'd go out, I could do dual, both safety and health, though I really enjoyed doing industrial hygiene work. The areas you're probably most familiar with would be the assessment for chemical hazards. Second would be harmful physical agents. This is typically noise, but it also includes heat stress, cold stress, radiation. I think that's pretty much all of them. Biological agents, but less frequently would we look into those. Ergonomic factors does fall under their guys, but safety shares that as well. It's similar to the practice of safety, except it's much more science-based. So chemistry, physics, things like that. So the Z tables is basically everything under Subpart Z, which is 29 CFR 1910, 1000, and up. Now there are other standards there too, such as you can see on here, bloodborne pathogens. We had talked about that earlier in the semester. HAZCOM, talk about that in another lecture. It talks about placards, talks about chemical hazard controls in laboratories as well. So there's a lot of information there, but they're pretty much all health related. Earlier in the semester, or in the course, I shared with you, I was looking things up in the NIOSH handbook. And so that's something that I want you to be aware of, is that you can go to NIOSH and they have a lot of information, health-related stuff, sampling and monitoring information, and basically specific information related to all different forms of health. The pocket guide is something I use quite a bit in my practice. Look up a chemical, get some chemical information about it, or some exposure information about it, how it should be sampled, things like that. It's just something I use a lot. Back in the day, I actually had to use the physical book itself. So what is industrial hygiene? Basically, you're just doing the same thing in safety, except you're really focusing on the health aspects of it. But it's a little bit more complex than that, because you need to know what you're sampling for. So there's no like magical Star Trek, Star Wars device that you can just turn on and it tells you what's there, how much is there, and things like that. You have to study the work itself and what could be produced, and you have to study the safety data sheets and basically know a lot about chemistry. I feel like we kind of looked at something like this, but what I want to get to is the special expertise here at the bottom. Inhalation hazards, respiratory hazards, so some people specialize in that. Infectious disease is a whole other group. When this PowerPoint was originally made, it was before the current pandemic. Radiation hazards, I'm a little bit weak in that area. If I had to take over a role, I would then, I know where to get the information to remind myself, to refresh myself. And then ergonomics is something that I've pretty much always done. Here it kind of just tries to define the difference between safety and health. So an injury tends to be something, you get your hand caught in something, or you fall, or you try to lift something heavy and right away it hurts you. Whereas an illness is something that happens over time. And so the exposures are more complex, more dynamic. And you might have to take symptoms in order to investigate what they may have been exposed to. And sometimes people's response to exposures to chemicals or harmful physical agents or infectious agents manifests in different ways. And so it's kind of practicing safety from a health perspective, but it's also kind of practicing medicine a little bit as well. Though you're not prescribing, you're just trying to evaluate. That's basically it. There's two types of exposures. There's acute and then there's chronic. Acute is short-term, high dose. Chronic is low dose over time. To give some examples here. So the top one, that's dermatitis. So they're exposed to something that gave a dermal allergic reaction. The bottom, it's talking about silicosis and asbestosis or mesothelioma. This is something that you get exposed to over a career, and then years later, sometimes decades later, you develop lung cancer. Here's the different routes of entry. Inhalation is probably the one we're most familiar with. Ingestion as well. Anything that can be inhaled can usually also be ingested because it gets caught in the mucous membrane in our throat, and then we either expectorate it or we swallow it. And when we swallow it, we're ingesting it as well. Of course, there's also incidental ingestions. Dermal absorption, some chemicals can actually be absorbed through the skin, though the skin tends to be a good barrier to things. And then there's injection, whether it's a mosquito or an accidental needle prick, or you cut yourself and there's a direct entry for a chemical or another agent. From a toxicology perspective, we can talk about dose. And that is, there's a certain amount that when you're exposed to it, then there'll be a negative response or a negative symptom. So there are lower levels that are considered safe exposures, which is why we have the permissible exposure limits. If somebody's exposed to a certain amount over an 8-hour period, a good percentage of the population will become ill due to that. And so you aim to try and keep that exposure or the dose they receive over an 8-hour period below that, or not at all, I should say. Toxicity, some substances at lower levels have no effect or positive effect, but then there's a certain point in which it becomes toxic to the body. Certain chemicals affect certain target organs within the body. Kind of depends how the body processes it. And then detoxification is the body's ability to remove it. And it says the liver here, the kidneys are another filtration organ. And so those two tend to get, but then you can have your central nervous system attacked, respiratory system attacked. It depends. I want to quickly differentiate between a toxicologist and an epidemiologist. Toxicologists, what they're doing is they're testing a dose response in a sample or a cohort of a laboratory animal, typically. And again, they're looking for what dose gives a response. Epidemiologists, on the other hand, study when there's been a real world exposure. So epidemiologists right now are very, very busy with the pandemic. They're trying to understand exposures and results and things like that. And so epidemiologists, there's been a natural exposure and they're studying it. Toxicologists are in a lab and they're forcing the response onto lab animals. Here is the dose response. There can be two different types. Now you may think the dose and response is a perfect line, but it's not. There's kind of it's usually some sort of curve in which there's you start dosing and there's actually no response, and then it starts coming up, and then it reaches a peak and then it goes back down. Just depends. One group you need to be aware of is the American Industrial Hygiene Association. Their counterpart would be like the American Society of Safety Professionals for safety professionals, American Industrial Hygiene Association for the industrial hygienists. So I'm going to give you some examples here. If we were in a classroom, I'd have a whole set of devices I could share with you. They're not mine. They belong in the IH lab, another professor. Here, talking about carbon monoxide. Up in the upper right, I think it'd be your right, the way you're looking at it. That's a household or a residential carbon monoxide detector. I can't really see what brand it is. It's called like Nighthawk or something. Every house should be equipped with some form of carbon monoxide because the burning of natural gas, the burning of propane, all these things give off a certain low level of carbon monoxide. And when a burner is not operating properly, or if the exhaust system is not operating properly, you can have a buildup in the house. And you want to keep it below 50 parts per million. Hopefully a lot lower than that. I know Nighthawk, I think, has a certain level at which it'll start alarming. what you really should do if you get that is get out of the house. You should open doors, open windows, shut off gas systems. Make sure everybody's okay. Every year people die from carbon monoxide poisoning, and it's, it may be a propane heater that wasn't well ventilated. Maybe it's a furnace or a hot water heater that the exhaust port was blocked or something, and it builds up. And carbon monoxide is a chemical asphyxiant, which means when we breathe it in, our blood, our red blood cells, which carry oxygen throughout our body, prefer carbon monoxide. They prefer it. And so given the choice between the two, it takes the carbon monoxide. And what that does is, in our body, it feels like we're not getting oxygen. And again, chemical asphyxiant. We're suffocating because we're not getting oxygen. We breathe it off over time, but it takes more time to breathe off than breathe in. Here is examples of noise dosimetry and sound level meters. So I gave a lot of, I'll go over what I provided to you with this lecture. A lot of information. Noise sampling is something that a lot of companies need. Whenever workers are exposed to an 8-hour time-weighted average of 85 or greater, they're required to have a hearing conservation program. We'll talk about that in a few lectures. But you walking around the sound level meter, what it does is it's sort of a survey of where you want to do the full shift sampling for noise to determine what they're exposed to, because then you can investigate ways to suppress or eliminate the noise that's being produced. Or if you can't do that, then equip your workers with hearing protection. And you need to know what level based on what they're being exposed to. This is air sampling equipment. We've got some dosimeter tubes, I guess is what we call them, the piston pump. These are colorimetric, so you draw air through it a certain amount, and whatever chemical you're sampling for changes the color in the column and lets you know approximately how much is there. It's just an initial test, just to find out if there's anything there. Up on the right, I think that might be a TLV sniffer. It detects organic vapors, different levels. At the bottom, we've got some carbon tubes, which is typically used for sampling organic volatiles. And then you've got a whole set of Gillian pumps and calibrators that a worker or workers will have to wear for over an 8-hour shift. And then you're collecting, you basically clip it within 6 inches, usually on their collar of their mouth, so that you're sampling the kind of air they're breathing. And you send it to the lab for analysis, and then you do the calculations as far as what they're exposed to. Oh, this equipment is for heat stress. The bottom left is a heat stress monitor. It monitors dry bulb temp, wet bulb temp, and globe temp, which is radiant heat, so like from the sun or certain lamps. Bottom middle is a sling psychrometer, and that's a quick way to get wet bulb and dry bulb in order to calculate relative humidity. And then on the right, we've got some velometers. One is a propeller, one is a hot wire anemometer. And so it's a combination of all these things that you determine what is the heat impact on the person. And then you have to take into account the heat that's being generated by the work they're doing. And you can use tables from ACGIH in order to determine whether there needs to be a work rest schedule, if workers need breaks for water, or like a Gatorade, with an electrolyte. Not supporting any one particular brand. There's like Squench and stuff like that. Or whether you need to provide a cooling station for them to make sure that their body core temperature can be controlled or maintained at a safe level. So I mentioned ACGIH, American Council of Government Industrial Hygienists. ABIH is the group that provides the accredited exam for the CIH designation. And then CDC and WHO. These are groups that you probably hear about on the news quite a bit because of the current pandemic. So I kind of went over everything, in a nutshell, kind of gave you an overview of what it's like to practice industrial hygiene, which I still enjoy. I love that part of the job. So I've got some pictures and I got some other things to show you. So here's a collage of different types of sampling material. So this is like a passive dosimetry badge. You've got a bunch of cassettes here. Cassettes can be used for sampling different things. A dust wipe could be for like lead. And then you got all kinds of sampling tubes or sorbent tubes to be hooked up to a pump. So somebody had posted this and I thought it was cool, so I thought I'd share it with you. That's all you needed from that. And then I've got links to some OSHA stuff. So they have information booklet on industrial hygiene. We've got something about how to do an exposure assessment. All things that if you were ever asked a question, you could find, because it's all available here on the website. Here's the Z tables, and they've kind of updated this so you can actually look things up. And then the NIOSH Pocket Guide, the thing that I use quite a bit. Yes. All right, what else did I provide to you? So I've got a few videos. One from NIOSH on health hazard evaluation. It's short, it's only 2 minutes. And then one from MSHA, obtaining a dust sample. MSHA is a company that provides IH equipment. So that's just under 4 minutes. I also provided an IH form. I believe this is for noise. Let's see here. Oh, sorry, I got to bring it over so you can see it. So I've had students go out and do full shift noise sampling for companies who need help. And so this is something I found, so the students had a guide as far as what they needed to collect, questions they needed to ask. This one's fairly thorough. It's from Brookhaven National Laboratory, very well-respected lab there. And it's got some other information about ear protection, how to properly put it in your ear and stuff like that. So I thought that was pretty cool. I think for one of my clients, I put together information about the cost of hearing loss and from a work comp perspective or from a legal perspective. So I looked up all this stuff and I provided them with some information just so they know how much it costs. Because that's usually something that management needs to be told, is that, you really need to spend, 10 grand on developing this program, and the equipment's going to cost, another 15 grand. That's 25 grand. Well, that's not worth it. Well, look and see how much just one claim costs or one legal case costs. And you can see here, here's some other things as well. Just trying to convince them that it's, what it really takes to protect people is worth it. What is it? An ounce of prevention is worth a pound of cure, or something like that. I think that's what the term is. What else did I provide here to look at? Oh, I've got an audit report. I've got a walkthrough of a plant, and I think you'll like it. I'm not going to play it here because it might mess with WebEx, but please watch this. This is me putting on a GoPro and walking through a place that we were going to do noise sampling for. And go ahead and have the sound on. I think it's really loud. We had some over exposures there. So, and then here's the report for that same place. So you can read this, and then watch the video. And it kind of talks about everything here. This is one of my more recent reports, I believe, and so I'm getting better at it. Providing more information, providing good resources for the employers, because I want them to be able to protect their workers and also protect them in case they have an OSHA inspection. Shared my methods. Oh, it was back in 2018, 2 years ago already. I feel like I just did this last summer. Penalty reduction amount, so I explained to them how I calculated it. As you can see, it was the old amounts. It's not the current 13,000. Explained how I came to calculate all the mock citations that I was giving to them, and how I ranked them and rated them and gave them penalty adjustments. That's what I meant to say. Here's a summary of them. Total. So the gravity base was 75,000 basically. They got one it was 26 after it. Here's the shift sampling. Hearing conservation program, yes. So they were over the 85 or above the 90. 1, 2, 3 were. 3 were above the 90, which now requires that they wear hearing protection. And I helped them, and they actually did put it in place right away. So good for them. We had a robot that wasn't properly guarded, or a piece of equipment when operated. Here's a picture here. And the controls, the emergency controls, had to be reached by a stick. Very dangerous. All you have to do is rewire it so that it's right here, then you don't need a stick. More stuff being unguarded. And so now that we're near the end of the semester, this report is you'll probably be able to understand it even more than if I had shared it earlier in the semester. So I got interlocking gate here. We got labeling, two-hand actuator. You guys remember this stuff. Some of you have even recommended that in our one-on-ones. General information about how to develop a comprehensive safety and health program with resources and comments and everything that's good. And then I gave them a checklist. Oh, I guess I did include it here. I guess I provided it separate, but those are my appendices. So I think that was basically it. So I gave you a lot of information here, but really try to just give you an overall comprehensive look at what it's like to practice industrial hygiene. I love it. Again, I really enjoyed going out, and you're almost like a detective. You're given little pieces of information. You got to dig in yourself and do some research and study, and I think that's why I liked it so much. But it was long hours because you'd have to full shift sampling. Starts before dawn. That you have to calibrate your equipment and get everything together, and then drive to the site. You got to be there before the shift starts, and then you talk to the workers and let them know, you're going to be wearing this throughout the day. Give them instructions, get it going, check it. And then they hopefully set you up in either an empty office or a conference room. And you're just kind of filling out paperwork and reviewing things. And then every 45 minutes to an hour, you go walk around and you check your equipment and you make sure everybody's okay. Sometimes you have to switch out sampling tubes or cassettes because you don't want breakthrough. You don't want to get them so full that it's 100%. You want it to be below 100% because then it's a more accurate reading. And then at the end of the shift, end of the 8-hour shift or whatever it is, you collect all your equipment, you make sure all of your samples are properly labeled and under your control, and you fill out all the paperwork, you drive back to work, you post-calibrate, and kind of compare everything and get your samples ready to be sent to the lab. So it can be, a 12, 15-hour day when you do full shift sampling, and you're usually doing it about once a week, maybe once every 2 weeks sometimes. But that extra time was given back to you in vacation. And so, basically it was another day or possibly 2 days a month typically. And I kind of like that. That was kind of a neat deal. I'm babbling. I'm going on and on. But anyway, so check out all these resources I provided you. They're all awesome. They're all excellent. I still use them today because I do enjoy this stuff. So that's about it.